This tutorial will teach you how to factor by grouping. If you're following along in your notes, then put this in your table of contents using the appropriate page number. You'll notice that I wrote an example here underneath the topic, and that's to kind of help you understand that factoring by grouping is a new method for us, because when I look at all four of these terms, they don't have anything in common. So there's no GCF, and it's certainly not a difference of two squares. So technically, this sentence looks like it cannot be factored. But that is not true. It can be factored, and that's what you're going to learn how to do today. So by the end of this lesson, you'll be able to say that you can factor a polynomial by grouping, and these are the four things that you're going to be working with. Identifying a GCF factor, factoring out a -1 or some other negative value in order to change the signs of your terms. The third thing is you may need to use the commutative property today to commute your terms so that they are in the same order. And then the fourth one is understanding that the distributive property will allow us to combine our groups or simplify our groups in a different way. So let's get started. I'm going to ask you to pause the video here and read through these steps. I know they don't make any sense right now, but read through them so that as I'm talking through an example, they will start to make sense to you. Resume the video when you're done reading. Okay, here we go. We're going to start off with our first example, and it has 4 or more terms, and it has no common factor. There is no GCF that all 4 of these items can be factored out with. So we're going to start looking at our problems in a different way. You know, gosh, it sure would be nice if this was just my problem, right? Because these have a GCF. Or it sure would be nice if maybe that was just my problem, because these two have a GCF. And that's what factoring by grouping does. It basically allows you to focus on one part of the problem at a time to factor out some sort of GCF. So take a look at my entire first example here. I've worked it out for you. Pause the video and take a look at what you see in this solution. All right, have you paused the video? Did you take a chance to look it over? So let's start talking about those steps we had in our last screen here, right? 4 or more terms, group pairs of terms with common factors, right? So we have 4 terms. We created 2 groups. Those 2 groups have common factors. And then our third step was to factor out a GCF, right? Factor out a GCF here. So I factored out a 4 from my first group. I also factored out an R, so that gave me a 4R term. When I divided these values, the remainder was Q plus 2. In my second term, I factored out a GCF of 3. I wrote down my 3 here, and when I was done dividing, guess what my remainder was? Q plus 2. You see that? That's a match. Now let's talk about my actual final answer here. How did this happen? Right? How did that happen? Well, when I take a look here at this step, it says that I'm going to multiply 4R times the quantity Q plus 2. I'm going to multiply 3 times the quantity Q plus 2. So I can say that I'm going to multiply 4R and 3. I'm going to multiply both of those things by Q plus 2. I'm going to multiply 4R and 3 by Q plus 2. So if I'm going to multiply Q plus 2 times something, I could write it like that. Does that make sense? I'm going to multiply something by Q plus 2. And what I'm going to multiply it by is 4R and a 3. So this becomes our plus sign. So now that last step should make sense when I say, take your outside terms, these are the outside terms, combine them into their own binomial. Then take your matching term and write it once. So here's the good news. If you don't get a matching term, you know you're doing it wrong. All right, let's take a look at another example. Here we go. Let's start from the beginning. Look at the entire problem. If there is no GCF, try grouping it into two separate sections. The first quantity has a GCF of A, a remainder of B plus 5. My second quantity has a GCF of positive 2. Now this is important. That symbol is important and necessary. So positive 2, and the remainder here is B plus 5. I've got that repeat. I've got those matching terms just like I wanted. So I'm going to take my outside values, A plus 2, because both of those things are going to distribute to multiply B plus 5. So I can simplify this down to this product. That is the factorization of this 4-term polynomial. Let's do it again. You ready? Break it up into two groups. Look for your GCF. Write your remainder. Look at your two terms. Factor out your GCF. Write your remainder. Oops. Make sure you have your match. Write your outside terms as the first group and your matching terms as the second group. Although you could even write this one first if you wanted. And then you could put this one second, because you can commute two products. All right, let's take a look at one more. I think you're getting this. Group out my first two and my last two. Pull out my GCF. Write my remainder. And when I look at this second term, they actually don't have a GCF. But I have to factor out something. So if there's nothing to factor out, then their greatest common factors are 1. So I'm going to write a positive 1 here. And I can't leave it invisible. I mean, I could, but leaving it invisible makes it hard for me to understand where my other two terms are coming from. So I'm going to fill in that invisible 1, which doesn't change the quantity at all. And now I have that matching quantity that I always like. My first term here will be 7x plus that invisible 1. All right, I think you're ready to try a few on your own. Get your pen and pencil ready, pause the video, give it a try. All right, you ready to check your answers? Here we go. Pause the video and give this a really long look over. Check all of your middle steps and your final combinations. All right, now we're going to move on to something a little bit harder. Okay? We're going to try factoring this time by using an additive inverse, or factoring out a negative value, or potentially commuting the terms. So let's see what we've got here. It can be helpful to recognize when binomials are additive inverses of each other. That means sometimes, like in my first example here, when I group my polynomial and I pull out my GCFs, sometimes my second quantities are not quite a match. But they're super close. They have the right terms, they just have the wrong signs. So this one has a negative b, and this one has a positive b. This one has a positive 6, and this one has a negative 6. If I could just make those additive inverses, right? If I could just make those opposite signs, that's what an additive inverse is, then I would have a perfect answer. So we're going to do two things here. First is, I have the wrong signs. The second thing is, they're not in the same order. Right? You see that here? I have a variable, then the constant, and here I have a constant and then a variable. So here's what we're going to do. We're going to go back, we're going to rewrite this problem, and we're going to commute these two terms. And by doing that, and I group it, I now have my b's in my first terms and my constant here is my last term. But I want to talk to you about something important here. The symbol in between our two groups always needs to be a plus sign. And if it's not, I need you to take that negative sign and push it into this group, like that. So that now your leading coefficient is negative. That's important. That's your hint that, hey, wait a second, I probably shouldn't have a negative leading coefficient. So instead of dividing everybody by positive 7, this is a reminder to me that I'm going to divide everybody by negative 7. And that's where I got that minus sign from. From understanding that my terms were not quite right? They had the wrong signs. So we're going to factor out something called a negative 1 here, or in our case, a negative 7. By dividing by a negative, you can switch the signs. So let's just get into it. Group it. Check for your negative sign in the middle. If you have one, take that, make it positive, but push the negative sign inside that group. So we're going to take that negative sign and we're going to push it inside that group. That's our reminder that we probably need to divide by a negative. So over here, GCF is n, r plus 5. Over here, the GCF is negative 2. And the remainder is positive r, and now positive 5, because a negative 10 divided by a negative 2 is positive 5. Set up your two outside factors, set up your repeat factor, and voila. Let's take a look at another one. Here we go. Group it. Make this a positive, push the negative sign in. Alright, I'm going to pull out a 3y, giving me x plus 5. And then over here, I'm going to try factoring out a negative 4. And that gives me a positive x and a positive 5. Perfect! Perfect match. First group, second group, all factored. Alright, I think you're getting this. I'm going to show you one more, because it can get a little tricky, just like that first example I showed you. I'm going to factor out here in this group a p, leaving me with 3 minus 2p. And then over here, I'm going to push the negative in, make that a positive. And I'm going to factor out, a negative, let's see. I'm going to factor out a negative 9. And that gives me a 2p minus 3. Alright, so I got some trouble now. I do not have a match. So let's think about this. Two things we need to see. Are they in the right order? No, they're not. So I could simply commute these like this. I could commute that. Don't have to start the problem over. Don't have to change anything. I could commute that. But even after I commuted it, I still had a problem. This one has a minus 3. This one has a positive 3. This one has a plus 2p. That one has a minus 2p. So, bummer. Do you remember what you need to do if you don't have the right signs? Yeah, typically it's divide or factor out a negative. Now, the problem was I did factor out a negative, and that's what messed everything up. So let's see. What if, now that I've done this problem, I'm going to go back and I'm going to start it again. And sometimes I want you to do that. It doesn't mean you're wrong. It just means that as I'm working, I noticed I didn't like the outcome. I didn't like the outcome, so I'm going to start over. And I'm going to commute these terms immediately. I'm going to take this minus 18p and this plus 27, and I'm going to commute them from the beginning. And now, I'm going to group my problem. It has a plus in the middle, and so now my leading value is not negative, right? So that little trick of a leading negative kind of tricked us in that last one, right? So typically a leading negative means you divide by a negative. But because our terms were commuted, I technically didn't have a leading negative. So again, I'm going to pull out a p. I'm going to get a 3 minus 2p. And this time I'm going to pull out a positive 9. And I'm going to get a 3. Oh, I forgot my p here. 3 minus 2p. Now I have those matching terms, and now I have a perfect factorization. All right, listen, that wasn't easy. You may need to rewind this video. As you're working on the practice problems, you may need to go back and look at my work. But I think you're ready to try some questions. So pause the video now. Now be careful. Not all of these need a negative factor. Only do it if it's necessary. So look closely at the problems. All right, unpause the video and let's check your answers. You see how you did. All right, I hope you did well. This concludes the lesson, but in order to get credit today, I'm going to ask you to answer this exit ticket and send me your answer. Right? So send me your answer so you can get some credit for watching this tutorial. You can private comment in the Google Classroom under the video link, or you can email me your answer. But don't public share it because I don't want anyone stealing your answer. All right, that concludes our video on factoring by grouping.